Hey guys, guess what? We have made it to the end of this semester. This is our last video. Can you believe it? We've done a whole year of flipped classroom videos, and you've learned algebra from this new model of instruction. So I just want to thank you for trusting me and for sticking with me. I think a lot of you know that when you actually watch the videos, it helps a lot. So today we're going to finish the packet algebra section. Let's look at our schedule here. It says week 4. Remember, we're not doing week 5. So before I forget, on week 5, we were supposed to do K and L. Cross through K and L. We're not doing K and L. Okay. So week 4, we are watching the video, that's what you're doing right now, and then you're going to do G, H, I, and J. I know that sounds like a lot, but it's really not. Okay. So because it's just like 4 multiple choice questions on each page. So let's go ahead and go to page G. Now, I really would suggest that you guys have your journal handy because we're going to be referring back to some notes. We're going to be starting with 6.4 exponential functions. So here we are. Okay. Alright, so let's look at number 1. I'm on page G, and I have exponential functions 6.4 notes out to refer to. So it says the graph below models y, the number of milligrams of a certain medication that remains in a person's blood x number of hours after taking the medication. If y is the exponential function of x, what is the equation of the function? Okay, so if we look here, we can look... So if we look at at some examples in our notes, like this is the second page of that 6.2, we look at some graphs where we're looking at exponential function here. We can see that, like in this one, 3 is where it crosses that's their y-intercept. So remember the parent function of an exponential function is a b to the x, okay? And your a is your y-intercept. Your b is your your b is the number in the parentheses that you're multiplying by, and then your x is, of course, the exponent. Okay, so let's look at this right here. Where is this line crossing the y-axis? It's crossing at 160. So we know that 160 has to be the first number. That's the case in all of them. Now, we know that x is going to be our exponent. We don't know what it's increasing by, so all of them are x. The x is exponent. What we're trying to figure out here is our b. What is our b? Because we know that the parent function of an exponential function of an exponential equation is abx to the x. Okay, so we're trying to find this piece. We know the a is 160. We have to figure out the b. To figure out the b, what I like to do is I like to see what it is when your x is 1. What is your y? Okay, so I like to start with a 1 because that's just easy to do. So we're going to start with with 1. Okay, so when x is 1, y is 120. Alright, so y equals this right here. Okay, so if our x is 1, that's your exponent. Your y, this is going to have to equal 120, because 120 to the 1 is, we're trying to figure this out. 120. We want to find 120 to the 1 power. That's just 120. So which one of these equations, when you multiply them together, 160 times 0.75, 160 times 0.5, times 1.25, or 0.9, which one of those is going to give you 120? Because that's what it is when x is 1. Okay? And this is your x. Alright? So which one of these is 120? Let's see. 160 times 0.75. Oh, right there, 120. So your answer is A. Okay? And it would be the same. So if x was 2, and that's not a very pretty point, but it would be like 90. So this number would be 90 if it would be 1.25 to the second power, because x would be 2 times 160, and that should equal 90. Okay, but you could check it if you wanted to, but we already did it with just x equals 1, so 120. Number 2, the table gives coordinates of 4 points in the graph and an exponential function. So on our notes, we have the same thing, but our table was up and down, so we can just redraw it right here just so it would be the same, okay, as these tables in our notes. And it would help us maybe when x is 0, 1, 2, and 3. So when x is 0, y is 3. When x is 1, y is 12, 48, and 192. Okay, so remember what we did here is we were trying to figure out the pattern with the x's and the y's. So that's what I'm going to do here. The pattern with the x's is +1. And the pattern with the y's is what? Times 4. Okay, so times 4. So now we know the parent function of exponents is abx to the x. We can figure out here what that is. So I like to start with x at 1. When x is 1, y is 12. So which of these equals 12 if you plug in 1 for x? Well, you have 2 of them that equal 12. You have g and h. So now we have to go to 2. When x is 2, so when the exponent is 2, your value needs to be 48. So which of these equals 48? 3 times 4, well, remember our PEMDAS, okay? PEMDAS is, please excuse my dear sign, parentheses, exponent, okay? So we need to do 4 to the second before we multiply times 3, because you do the exponent before you multiply. So let's do 4 to the second, that's 16 times 3 is 48. Ooh, that checks out. Let's just check this one, it should not work. 3 to the second is 9 times 4 is 36. So when x is 2, y should be 48. So that is a clear there that the answer is G. Okay, which equation best describes the line on the graph below? Well, we could see that it's not crossing at a very pretty point here at the y. But what I want to do here is I want to put it into, we need to put these into y equals. That's going to help us, since we don't have a graphing calculator. So let's go ahead and put this into y equals, this first one. So we would say minus 2x and then divided by 6. That's really fast, okay? I just went really fast. So y equals, I'm going to just simplify this, 4/3 minus 1/3 x. Okay. So this is our, because it's below, in front of the in front of the x, that's our slope. This is our b. 1 and 1/3. That could be it. And it is a negative slope. Is it going down at 1, 3? From here, 1, 1, and over 3? Possibly. Okay, let's try these others. What would this one be? This would be plus 2x. Minus 2x. Minus 2x, and then divided by negative 6. So this is going to be a y equals negative 4/3 plus 1/3 x. It's going to be a positive. That's not positive slope. That's going to be a positive end. This one, minus 2x, divided by 6. This is going to leave us with y equals 8. Negative 8 over 6 is negative 4/3 minus 1/3 x. Okay, So, ooh, it's a negative slope, which is still true, but it's telling us our y-intercept is negative 4/3. That's negative 1 1/3. It doesn't cross at negative 1 1/3. That's here. So let's just, this one should be the same except for it's going to be flipped because this is minus. So you're going to end up on this one, if you were to do that one, you would end up with 4/3. Wait. Yeah, 4/3 plus 1/3 x. That's a positive slope. It's not a positive slope. So A is our answer on that one. All I did was put it into y equals and just match it with that up there. Okay. Another way you could have solved this is you could have just picked a pretty point, like right here. This is negative, this is 4, 0. And if you were to, your x is 4 and your y is 0, if you would have subbed in a 4 here and a 0 here, it should have equal 8. So 2 times 4 is 8, plus 6 times 0, which is 0, is going to be 8. That would check out. That's another way you could have solved it. There's multiple ways you could solve that. Population of a town decreased by 4.7% annually for the past decade. The population today is 4,670 people. Which function models y, the population of t years from now, assuming the rate of decrease does not change? Alright, so let's find this in our notes. Okay. This is the one we did, and I told you to tape it in. Exponential growth and decay. This is going to be decay. It's decreasing, so it's decay. And remember, this is our formula. Y equals A, 1 plus R to the t. Okay? So A is the initial amount. The initial amount is what it is today. So y equals 4,670. Okay. 1 plus R, the rate is 4.7%. Okay, so that's in percent. We have to put this into a decimal. Okay, so we're going to go okay, so that's 0.047. So 1 plus 0.47 to the t. Which one of these is the answer? This one. Okay, because it's 1.047. Yay! Okay, that's just straight from your notes. Straight from your notes on that. It's okay if you don't remember that offhand, but that's just straight from the notes. Alright, so that's G. Let's look at H. There's just 2 problems on H. A math textbook showed the graph representing the function. Okay, so this is just good old y equals mx plus b. So which of these it shows this function? Crossing, their b is a 4. Alright, so it's going to cross at 4. So that's going to eliminate h. Okay, and then your m equal, let's write the b. b was 4 and your m is 3/4. So your m is positive. So that is going to eliminate j, because j is a negative slope. So now we're down between f and g. We just need to check it. So what this means here is it's going up 3 and over 4 to the next point. So if you start at 4 and you go up 3, you're going to go to 7 and over 4, and that looks like it's a little too steep. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. That looks pretty good. This line is a little bit more like what it should be. Okay. 6. Which graph corresponds to the linear function that's represented in the table below? It tells us it's linear, so we know it's going to be a line. So these are all coordinate points. Which of these coordinate points are on the graph. On the line. So negative 3, 12. Negative 3, 12. Well, we can't really tell that one. Negative 1, 5. Negative 1, 2, 3, 4, 5. Nope, not that one. Negative 1. Nope, not that one. Not that one. Negative 1. 1, 2, 3, 4, 5. Nope, 5 right here. Yeah, that could work. Let's try these others. 1 and 2. 1. Oh, 1 and negative 2. Yep. And then 3 and 9. Negative 9. Well, these 2 points lie directly on it. So that's going to be D is your best option, because all I did was I put these in coordinate pairs. And I tried to see, and so on. You could do the rest. And I tried to see which one of these points, all of these points had to fall on the line. And this is the only one that had the same, that had points on that, those points on the line. Okay, page I. The equation y equals 10 times 1.2x. So we're back in exponential notation. Models the change in the price of 1 ounce of precious metal, where x is the time in years and y is the price in dollars. Which graph represents this relationship? So 10 is going to be where the graph starts. They all start at 10. So we can't eliminate it there. And then I always like to look at 1. What is it at 1? Because if x equals 1, then this one is that your y is going to equal, at x is 1, y is 20. So let's see if we were to put a 1 in here for x, if that would equal 20. So what's 10 times 1.2? It's not 20. So I'm going to tell you right now, it's not going to be f. We can go ahead and solve this. 10 times 1.2, oops, is 12. So which one is 12? 1 at 12. Okay, it's possibly, looks like G is a little too steep, but it looks like it's either going to be H or J. Okay, so 1, that might be 12, that might be 12, so we're going to go to 2. Okay, when x is 2, what is the value of this equation? Alright, so if my x equals 2, then it would be 10 times 1.2 to the second. So remember, PEMDAS told us we need to do this 1.2 to the second first. That's 1.44 times 10, 14.4. So which of these is when x is 2, y is 14.4? 2, no. That one, this one is definitely not 14.4. It looks like J is going to be our answer. Okay? Number 8, which graph represents the equation y equals x minus 4 squared? Okay. So if you had a graphing equation, a graphing calculator, you could plug this into y equals, graph it, and see. But we can go back to our notes. Okay. This is where we're getting into quadratics, okay? Because these are quadratics. So remember, this is a square, so x minus 4 squared. Your parent function is y equals x squared. That's what it says here. Okay. If it's positive, this one is just a little bit tricky because it is x minus 4 times x minus 4. It's a polynomial. So let's see here. Man, I wish I had a graphing calculator. Let's go ahead and skip this one because we don't have a graphing calculator, most of us, and if we did, it would be a really easy one to put in y equals. A bicyclist set out from her home for the town of Baxter, which is 80 miles away. The cyclist rode at a steady rate of 20 miles per hour. Which graph best models the entire ride? Okay, so the bicyclist set out from her home in the town of Baxter, 80 miles away. So the distance from Baxter is 80, okay, when she started her ride. So it's going to have to start at 80. So it's not going to be this one that starts at 20. It's not going to be this one that starts at 0 distance. It's either going to be J or G. Okay. The cyclist rides at a rate of 20 miles per hour. So in 1 hour, she should have rode 20 miles. That would put her 60 miles away. Okay. In 1 hour, nope, that's not right. This is the one that is the best. The table includes 4 points on the graph of a quadratic equation. Which graph represents the same quadratic equation as the table? Okay, so here again we have a quadratic equation, and if we go to our notes, we can find a table. Okay. Well, let's just look here. Where x is 1, y is 2. Let's just match it up. So let's just start. I like to start with x is 1. X is 1, y should be 2. At 1, y is 2. That works. This one doesn't work because 1 and 2 would be right here. That's not on the line. 1 and 2 is right here. That one works. 1 and 2, that's a little off. Okay. So we're down between C and B. So let's look at the others. 3 and 16. 3, 16. That would be way up there. 3, 16. That could work. Oh, that one's not working. 3, 16. So we already know it's either B or C. That tells us right there it's C. So what I'm doing is I'm just looking at the graph for x and y, and I can substitute those in and to see. So once you're done with that one, for this one, guys, well, on this one, let me just show you an easy way to do this. It's x minus 4 times x minus 4. We can FOIL this out, right? And it would be, first times first is x squared, outer is minus 4x, inner is minus 4x, and then last is plus 16. So we would get x squared, this cancels out, plus 16. That's what that equals. Oh, no, it doesn't cancel out. Minus 4 minus 4 is, negative 4 minus 4 is negative 8x, and then plus 16. Okay, so that's your quadratic there for y equals whatever. Okay, so we know that it is a positive x squared. All right, so it's going to be it's going to open upward, and plus 16, it's going to okay, because it was minus 4 squared, then right here, and then it goes up. Let's say D is our best choice on that one, just so you can have an answer. You would be able to check this with a graphing calculator if you did, and if you got something different, I'm just going through this really fast with you guys just to save time. You can check it on the graphing calculator. Let me know if I was wrong. I really just did that one super speedy. So what I just did with you is I finished that up with you. So now you have two options. You can go ahead and put all of your answers in the written answer document. Remember, you can skip K and L, or you can go to Google Classroom and fill out the answer document I put there, and submit that. And you should have gotten a call, or your parents should have this week, and it was going to tell it from the school district saying, you know, this is how we're grading things. It's not going to be 92 or an 87. If you have done your work and turned it all in, and you have shown, like, effort. So I need to see that you put some answers in. Just don't put anything in, but there's effort there. If you've been attending Zoom meetings or whatever, then you get 100. Woohoo! For the 9 weeks. If you don't and you haven't done anything, no work has been turned in, then you get a 69. So we're all going to go for 100 across the board. So turn all that in, get that Google Classroom, that document, that form submitted to me so I can go ahead and put your grade in, and we'll be done with Algebra 1, and you have a high school credit. So anyways, I hope that you guys have a great rest of your day, and we will be Zooming our last Zoom on Tuesday, May the 12th at 2 o'clock for Algebra. I'll see you then. Let me know if you have any questions. See ya.